So welcome to a lesson on optimization. Okay. So in the UK and in Canada, they use optimization with a S, and in America, we use optimization with a Z. Okay. Um, and so basically, what this is you're trying to maximize or minimize some relation or some function. Okay. This can be used for a lot of things, like to maximize or minimize costs. I know some of you are doing like, okay, like thinking about maybe doing a business for the future. If you want to do like beads or cake pops or anything. So you can just go ahead and use calculus to do optimization. So how do you do this? So the first thing you want to do is you find the equation, and in one variable is key. Okay. To maximize or min, remember what we said with max or min is you're looking for the derivative or the slope and you're setting it equal to 0. So you find the derivative, and then third step is to set it equal to 0. Okay. It can be pretty straightforward. So here's an example. So you have a square piece of cardboard. Let's just say that this is a box that you're trying to put your whatever your product is in. Let's make this a small box. So 3 centimeters, and we call this, since it's a square, this also has to be the same thing. So 3 centimeters as well. And you're cutting out small squares of the length of the box. So you're cutting out like a piece so that you can like fold it up, and you can cut this part out and you could fold it up and you can make an actual like box. Okay, so let's talk about what that would possibly look like. So your new box would look something, obviously it's not going to look exact, but it would look something like this. Okay, when you cut the corners out, so you could fold these up, and then you can have an actual like 3D box without a lid, obviously. Okay, so if we're looking to find out what the length and the width and the height of this box is going to be, okay, let's think about this real quick, right? So the whole length right here is 3 centimeters. We are cutting this piece, which is X out, and we are cutting this piece, which is X out. So to find, so we know volume is equal to length times width times height. So to find the length of this box right here, it's going to be, the length is going to equal 3 and minus this x that we're cutting out. So minus an x and minus this x that we're cutting out, another x. So the length is going to be 3 minus 2x. Okay, so volume is equal to length is going to be 3 minus 2x. Okay, our width, you should be able to see, is going to be the same thing, right? This whole thing is 3. We're cutting out this x and this x right here. So our width is also going to be 3 minus 2x. And our height, this is probably the hardest part. Okay, if I, this part right here is the one that's going to be folded up, so this length that we cut out is x, so we can see that the height of the box that we have when it is 3D, let's see if I could draw this. All right, something like that. Our height of this box when we fold it up is going to be x. So if I were to take this right here and I were to, multiply this to find out the volume. Let me just go ahead and take this over here. 3 times 3 is equal to 9. 3 times negative 2x is equal to negative 6x. If I multiply this, I could use box method. Negative 2x times 3 is negative 6x. Negative 2x times negative 2x is going to be positive 4x squared. And I'm going to multiply this whole thing by x. Okay, so 9 times x is equal to 9x. 6x, negative 6x is negative 12x, times x is going to be negative 12x to the second power, and then 4x squared times x is going to be positive 4x squared. Okay, if I were to take this and rewrite it like this with the x cubed term, 4x to the third. Ooh, good catch. So if I'm going to take this and rewrite it in like descending order, I would have 4x to the third minus 12x squared plus 9x. Okay, So now all it is a little bit of matching. So I have the volume of the box can be written as 4x to the third. Boom, that's what I have. Negative 12x squared, that's what I have as well. And then here it says kx, and I'm looking to find k. So the number in front of the x is 9. So I know that k is equal to 9 based off of what I just did. Okay. All right. So now here I'm going to find dv dx. So v is equal to 4x to the third. Let me just go up just to make sure that I have it. Minus 12x squared plus 9x. So I'm finding dv dx, which is the derivative of this. I think we've had enough practice with derivatives, so this is going to be 12x squared. That's going to be negative 24x plus 9. Okay, so first thing we want to do is we want to go ahead and write down the derivative. Second thing, so it says find the value of x that will maximize the volume of the box. So what I did is I went ahead, took my calculator, obviously turned it on, and I plugged in my original function, which is this, right? 4x to the third minus 12x squared plus 9x. Okay, so if I want to go ahead and just graph it, this is what it looks like, right? So I'm looking for the maximum point, which is this max point right here. So I can find that, right? I can hit second calc. I can do maximize or maximum. So left bound, sure, that point works. I'm going to go to the right of it. I'm going to go hit enter. I'm going to go to where I think it is, hit enter, and I get, okay, so that's about a half. X is equal to a half. X equals 1/2. Okay, so how do I do this algebraically, right? How do I do this like with this? So remember, maximize means I'm going to take my derivative, which is dv dx, which is equal to 12x squared minus 24x plus 9, and I'm going to set this equal to 0. Okay, so I want to see where did these values right here equal 0. I can see that 3 goes into all of these, so if I want to divide this by 3, I could. You didn't have to, but you could, so this would be 4x squared minus 8x plus 3 is equal to 0. So we want to see where this is equal to 0. So there's a calculator way that you could do this. So I'm going to plug into my calculator right here. Oh, what is going on here? I want this. So let me clear this right here. So how do I do this in the calculator, right? I plug in my function, 4x squared minus 8x plus 3 equals 0. So I'm going to put 0 here, and I'm going to hit enter. And I'm looking to see where the two graphs that I have, where they equal each other, where they intersect. So I can see that boom, boom, there are 2 points, okay? So to find out what that point is, I go option number, right, second calc, option number 5, which is intersection. So I'm going to go to where it intersects, hit enter, 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 and I get one of my values is x equals a half, or 0.5, which is what I had over here. And the second value, so this is where it's maximum, and the second value, option number 5, right? Again, I'm going to go over to the right. This is where it's the minimum, and guess, and it's going to be 1.5. So x is equal to 3/2, which is 1.5. Okay, so x equals 1/2 is where it was at the maximum. And how do I know? Because when I graphed it, I got something that looked like the maximum, minimum, and then it went up. So this is where it is at the maximum point. All right, so we're going to go ahead and do a couple of actual problems. All right, so the first IB question that we have looks very similar to the one that we just did. So this whole thing is 45. Let's call that the length. So here's our length, here's our width. So it says write down in terms of x the length and the width of our box. Okay, so the whole thing is 45. They're telling us we don't know how much this is right here, so this is going to be x. So we're taking out those two pieces. So our length is going to be 45 minus x minus another x, which is the same thing as 45 minus 2x, okay? Our width is going to be similar concept, right? This is x, this is x. So we have the whole thing is 24. We're taking out this x and this x. So our width is going to be 24 minus x minus another x, and that's equal to 24 minus 2x, okay? So there's our length and there's our width. Part A is done. We've gotten our 2 points, okay? Next one, it says state whether x can have a value of 12. So let's see. If x equals 12, right? If x equals to 12, what do we have? So our width is going to be, let's check our width because it's a smaller one, right? Our width is going to equal 24 minus 2 times 12, okay? 2 times 12 is 24, so our width is going to be 0. Can we have a box that has a width of 0? No. So x cannot, so this is what you have to write down, right? X cannot have a value of 12 because, right, if you substitute it in, our value has to be a positive number, and it cannot equal 0, okay? Write down the interval for the possible values of x. All right, so we know that, let me go ahead and create more space. So I'm going to call this part B2, okay? So we know that our length has to be greater than 0, and we know that our width has to be greater than 0. Okay, so to do that, we know that our length is 45 minus 2x, and we have to set that greater than 0. So let's go ahead and solve for this. So add 2x to both sides, add 2x. So I get 45 is greater than 2x. Divide both sides by 2. And you know that x put the greater than symbol. 45 divided by 2 is 22.5. Okay, so I know if I write it with the x first, x has to be less than 22.5. Okay, and then if I do the width, so this is going to be 24 minus 2x. I have to set that greater than 0. So I add 2x to both sides, just like I did before. 24 is greater than 2x. Divide both sides by 2. So I get x has to be 12 is greater than x, or x has to be less than 12. Okay, so if I combine this together, right, x is less than 22.5 and x has to be less than 12, I know that, right, I can't have 13 because x 13 is not less than 12. So I know that my values for my x, my dimensions of the box, have to be it can be between 0, but it cannot include 0. It has to be between 0 and 12 is going to be the biggest number. 0 and 12 cannot equal 12. Okay, so it has to be between 0 and 12 for my dimensions, because that's what it's asking me for part B2. Write down the interval for the possible values of x. Next one says for C, show that the volume of the storage box is given by this. So we're finding dvdx. Okay, so for C, we're going to go ahead and take our volume function, which we know is volume equals length times width times height. So we have our length is going to be 45 minus 2x times our width, which was 24, minus 2x, and times our height. Again, the corners of the box are folded up, so that's going to be x. So I'm going to take this and distribute this. So 45 times 24 is going to give me 1080. 45 times negative 2x is negative 90x. So negative 9. And then negative 2x times 24 is going to give me negative 48x. And negative 2 times negative 2x is going to give me negative 2x times negative 2x is going to give me positive 4x squared. Let's go ahead and I'm going to have to still multiply this by x. Let's combine these like terms right here. Let's bring this up over here. So I have x times 1080. This is going to be negative 138x plus 4x squared. And now let's distribute that x squared, and I'm going to get 4x to the third minus 138x squared plus 1080x. Okay. Yeah. So that is what is shown here, right? So that's what we got. Perfect. Shown. Perfect. Use your answer for part D. So what we just did right now, and we are going to find the value of x that maximizes the volume, right, of the box. So we're going to go ahead and take this right here, and we are going to find the derivative, okay? Find the value of x that maximizes it. All right. Oh, for part D, my bad. For part D, it says find dv dx. So part D, let me put D. Let me go ahead and erase this part right here. I should have already copied that down. So for part D, D says find dv dx. So I'm going to go ahead and differentiate this. So 3 times 4 gives us 12x squared. 2 times negative 38 gives me negative 276x. And this is just 180. So plus 1, no, 1080, my bad. Plus 1080. You can tell I'm getting a little tired. Trying to do 2 videos in one. Anyway, all right, so we went ahead and just differentiated. So that is part D. For part E, using your answer from part D, find the value of x that maximizes. So again, we're going to set this equal to 0. So we have 12x squared minus 276x plus 1080 equals 0. And again, we know that we could do this straight calculator. So I went ahead and I plugged it in. I'm going to go ahead and hit graph to see. Okay, so I don't see the whole curve. I know it should look something like this. So let me just go ahead and change my window. So I can change my X max. Let's just make it 20. See if we see that better. Okay, there we go. So I'm looking to see these 2 points of intersection. So to do that again, second calc, option number 5 is intersect. So boom, it puts it right there for me. So x equals 5 is one of them. So x equals 5 is going to be 1 point. And then to find the other point right here, I'm going to go over second calc, option number 5, and go over to the right. You can do that part. You're going to get 18 as the second part, okay? So we're looking to see where it is the maximum that maximizes the volume. So we know that to do that, you look at the original graph and you can see that x equals 5 is the one that's maximum. The 18 is the one that minimizes, okay? So x equals 5. So this is going to be 5 centimeters is going to be our answer for part E. Okay, so this is our answer for part E. For part F, the next thing that we're doing is it says calculate the maximum volume of the storage box. So if x equals 5, right, what is going to be our actual volume? So to do that, we're going to go ahead and take it and plug it back into our volume function, which is right here. So for part F, what we're going to do is do 4 times 5 to the third power, right? And again, I'm plugging it right here into this one or this one that I found. So it's minus 138 times 5 squared plus 1080 times 5. And if you take that, plug it into the calculator, hit enter, you're going to get 2,450 centimeters to the third power because this is volume, okay? All right, so that is point F. And then for part G, you just go ahead and sketch it. So we're going to go ahead and change our window. I'm going to go over here and we're going to change our window so that we can see the whole thing. So we have to notice that with this function, we are sketching the graph of V. So v is 4x to the third, right? All of that. So I plug that in. I can go ahead and take out my intersection because I'm not looking for that, and I have to hit graph, right? So when I do that, I should see that I don't see the whole graph. Okay, I see part of it. I don't see the part that it's maximum. So it says it wants my volume to be from 0 to 500. So I'm going to hit window, and I'm going to change my volume, which is so my x can't be negative. I'll leave that x max at 20, and I'll change my y max, which is our volume, from 0, and they want it to be till 2500. 2500. Okay, so now go ahead and hit graph, and okay, perfect. This is why they want the 2500. They want us to sketch that. So it says sketch the values and label the maximum point. So to find maximum, right? So you're going to have to sketch this right here, and to find the maximum, I hit option number 4, which is maximum. This is going to take a while. You go a little bit to the left, you go a little bit to the right, you hit guess. Come on. All right. Anyway, when you do that, you're going to get 5 comma 2450 as your maximum. It doesn't feel like working now, but you get the point. Okay. If you get stuck with this in doing it yourself, call me over and I will help you with it. But this is basically what you do. Go over to the left, you go a little bit to the right of the point, hit enter, and you go to where you think it is, somewhere over there, and hit enter, and it'll give it to you. So 5 comma 2450 is going to be the max. So you need to sketch that for this part. All right, so this next question looks way complicated for absolutely no reason. So we're looking to find the total area of the top of the candy box. They're telling us it's A. Awesome. Doesn't help me. So A is equal to, I can see 3 shapes here. I see a triangle, a rectangle, and I see another triangle. So to find out the area of this triangle, so I'm going to do area of a triangle is 1/2 base times height. So my base they're giving me is 12. My height is x, plus the area of this rectangle is pretty straightforward, right? This is just 12 times 9. So this is 12, this is 9. So 12 times 9 goes right here. What is that? 12 times 9 plus 1/2. The area of this triangle right here, we need to find out what that is, right? So we know that this right here is 9. Let me erase that. This right here is 9, and this here is 9, and this here is y, right? So 1/2 9 times y. Okay. So now I have to take this and just simplify it. Half of 12 is equal to 6, so that's 6x. Plus 12 times 9 is equal to 108, plus half of 9 is 4.5. I could write it as 9/2 y, and there is my area. Okay, so next thing we're going to do is it says show that a is equal to this lovely function right here. So we already found out what a is. Okay, so we have the 108. The 108 is there. We have the 6x. Okay, and we are looking for the last part, which is that this is the same thing as 486 over x. Okay, so let me back up real quick over here. They tell us that they want us to write it in this form. So a is equal to, they want the ay, so the one with the y term first, so that's going to be 9 over 2y. Then they want the x term, so that's going to be plus 6x. So plus 6x. And then they want the c term by itself, so we're going to put plus 108. Okay. And then if I look over here, right, if I match it, so the 108 is there, the 6x is there, and then this, something is weird here, right? We have 9 over 2y, and then over here we have 486x. So basically what we have to do is we have to try to figure out a way to get this y in terms of x, okay? So we have to get the y in terms of x. So how do we do that? All right, so I'm gonna go ahead, take a little commercial break. You see this triangle here? So this is a triangle. Here's our base. Here's our, let's call this height. So if I were to take this and draw this like this, I would have, right, the longer side is 12, and the shorter side is equal to x, okay? If I take this triangle right here and I do the same thing, and I redraw it, I can go like this, like this, like this, and I can see that my longest side here is y, and my shortest side here is 9, right? This is 9, okay? So in taking a look at what we have right here, we have two triangles, and these two triangles are similar triangles, okay? So here is what I mean by that. Similar triangles is like if I have this longer side, 12, over the shorter side of this triangle, x is equal to, I have the longer side, which is y, and I have the shorter side, which is 9. And if I solve this, and again, remember, the goal that I'm doing right now is I'm trying to get rid of the y, and I'm trying to get y equals to something with an x in it. So I'm going to go ahead and multiply this right here, and I get 108 is equal to x times y is xy. And remember, I want to try to get the y part by itself, right? Because I have this in terms of x, so I want to get everything in terms of x. So I divide both sides by x, and I get y is equal to 108 over x. Perfect, okay? So now that I have that, all I have to do is take this 108 over x and plug it in for my y. So I'm going to go back over here. So I have a is equal to 9 over 2 times y, which, boom, it's 108 over y, plus 6x plus 108. And now let's see if this is equal to the 486 over x. So 108 times 9 divided by 2, right? If I take my calculator, I do that out. Of course, my calculator is not going to cooperate. Okay, here we go. Second quit. So if I go alpha y equals, option number 1, I'm doing 9 over 2, and I'm multiplying it by 108 times 108 over, right, there's an imaginary 1 there, so times 108. I put y, I should have put x. There we go. There we go. Okay, good. So now I have 486. So good. This is what we had over here. So this is equal to 486 over x, just like they wanted us to show, plus 6x plus 108. Okay, so that's what the a is equal to. So we just showed it. Okay, so now we're going to take this and we're going to write it in terms of dA dx. So we're going to find the derivative of this. So to do that, let's go ahead and take this right here and rewrite it as 486 x to the negative 1 plus 6x plus 108, and find the derivative of that. Negative 1 times 486 is going to be negative 486. X to the negative 2, because subtract 1, plus 6, okay, is going to be our answer for the derivative. If you wanted to rewrite that as negative 486 over x squared plus 6, you could do that as well. So either that answer or this answer would work. Now Mark wants to do something crazy. He wants to minimize the area of the top box. Okay, so for part 1, C1, we're going to write down an equation that he could solve. So he could take the derivative, which is dA dx, and he could set it equal to 0. If you wanted to substitute what that is, you could write negative 486 over x squared plus 6 is equal to 0. You could write that down as well. Basically, what they want us to do now is to find the value of x. So we could have negative 486 over x squared plus 6 equals 0. You can use your calculator, or you could do it manually. Minus 6 from both sides, so negative 486 over x squared is equal to negative 6. You can go ahead and take the calculator, plug this in. What? I'm just gonna finish this by hand. There's not no objection. So this is over 1. You can use the calculator, right? Set this equal to y1, set this equal to y2, and see where they intersect. Negative 6 times x squared is negative 6x squared. Negative 486 times 1 is negative 486. So divide both sides by negative 6. And you're going to get x squared is equal to 81. And then you find the square root of both sides and you get x equals positive and negative 9. Since this cannot be negative because we're talking about dimensions, x equals 9 is our answer. Okay. Question number 3. So this one is very similar to the first question that we did. So we know that the whole thing is 30. So the length of the box minus the 2x's is going to be 30 minus 2x. And the width of the box is 18 minus the 2x's is going to be 18 minus 2x. So that's the length and the width in terms of x. State whether x can have a value of 10. So the easiest way to do that is to pick the smaller one. So if I do 18 minus 2 times 10, I'm going to get 18 minus 20, which is equal to negative 2. So no, we can't have a width that's negative. So the answer is no, because of exactly that, right? X cannot have a value that is negative. Write down the interval for the possible values of x. So to do that, again, our length must be bigger than 0, and our width must be bigger than 0. So if I do that and I say 30 minus 2x has to be greater than 0. Remember what we did last time is we just looked at the one that was smaller. So 18 minus 2x, set that equal to 0. Add 2x to both sides. So I get 18 is less than 2x. Divide both sides by 2. I get 9 is less than x, or x has to be greater than 9. I caught my own mistake. I put less than here. This is supposed to be greater than. Greater than 0, greater than, and then this one here, since I'm rewriting it backwards, x has to be less than 9. So that means that the interval for the box values is between 0 and 9. So for part C, show that the volume is given by this. So let's go ahead and do that ourselves. So the volume is 18, well, it's 30 minus 2x. The width is 18 minus 2x, and the height is x. I'm going to go ahead and FOIL this. When I do that, I'm going to get 540 minus 36x minus 60x plus 4x squared, and I have to still multiply that by x. Combine like terms, this right here is 540 minus 96x plus 4x squared. Multiply this by x. So when I do that, I get 4x to the third minus 96x squared plus 540x, which should be what they have. Yep, it is. So that is part C, because we just showed that. Now we're finding the derivative of that part. So D is finding the derivative of this with respect to x. So 3 times 12, let's just write dv dx is equal to 12x squared plus 540. Part E, let's use the answer, find the value that maximizes the volume. So when I do that, I'm going to set my 12x squared plus 540 equal to 0. And wait, I did something that I shouldn't have done. This is 12x squared. I ignore this. 2 times negative 96 is negative 192x, and then plus 540. I'm definitely going too quick. Minus 192x plus 540, and I have to set this equal to 0. Again, use your calculator, and you will see that x is about 3.64, or you'll see x is about 12.4. And again, if you don't see this, then please let me know. And we're looking to see the one that maximizes the volume. So we're going to go ahead, plug in the original to see which one is the one that maximizes it, and it is the one that says x is equal to 3.64 is the one that maximizes the volume. For part F, it says calculate the maximum of the box. So to do that, we're going to take our 3.64 and plug it into our function. So v is equal to 4 times x, which is 3.64, to the third power minus 96 times x, which is 3.64 squared, plus 540 times 3.64. Okay, take all of that, plug it into the calculator, and you're going to get that the volume is about 887 centimeters to the third power. That is our volume, and the last one is to sketch. Okay, so if you have trouble with this, please let me know. I want to try to keep the video to a minimum. Good job.